Hi everyone. In this lesson I want to talk about some intersections and unions. So I have a set A and a set B, and set A is the set that has the numbers 1, 2, 3, and 4 in it. So I'm going to write those over here. And set B is the set that has 3, 4, 5, and 6. So you see that the way I've arranged these in these two sets is that they overlap here at the points 3 and 4 because 3 and 4 are in both of those sets. Well, we say that the intersection of two sets consists of those elements in both set A and set B. Okay, so mathematically we would use this notation. A intersect B, this little upside down U is the symbol for intersection, and we can see that that would just be the set that contains the elements 3 and 4. Okay, so that's the what we mean by the intersection. On the other hand, the union of the sets consists of those elements in either A or B. So A union B, well, I know one is in either A or B. It's not in both of them, but it is in one or the other. So in fact, that's 1, 2, 3, 4, 5, and 6 are all in the union of those two sets. All right, so this is a simple example with a finite number of elements. In algebra, most of the elements or most of the sets have an infinite number. So here's an example that I have a set A that's an interval of numbers from minus infinity to 4. And B is another set that goes from 2 to infinity. So this would be, let's label, I'm going to have, let's put 2 on here. And let's put 4 on here, and A is the set of all the numbers to the left of 4. Okay, so let me get my color correct there. So there's set A for me. And set B, on the other hand, are all the numbers to the right of 2. So I'll start at 2 here, and then I want those numbers to the right of 2. And I'll have to change my color again, back to red. Okay. All right. So if I want to know the intersection of those two sets, then I want to know all the numbers that are in both A and B. Well, any numbers over here to the left of 1 are not going to be in set B. Let me go ahead and label these. So this was A and this was B. So anything smaller than 2 is not going to be in B, and at the same time anything bigger than 4 is not going to be in A. So you can see where they overlap is going to be between 2 and 4. Okay? And notice that at exactly 2, well, 2 is certainly in A, and you can see that because of the square bracket, 2 is also in B. So point 2 is going to be in the intersection. But over here at 4, notice that 4 is not in the intersection because even though 4 is in B, set A does not include 4. So I'd have to put that parenthesis on there. Now the union is any number that's in A or B. Well, all these numbers to the left of 2 are in A, so they're certainly going to be in the union. And all these numbers over here to the right of 4 are going to be in B, even though they're not in A. And so they're also in the union. And of course, anything in the intersection is also in the union. So this ends up being the whole real line from minus infinity to infinity. Okay? So let's solve just a couple statements here using the and, which has to do with an intersection, and the or, which has to do with a union. So if I wanted to solve 1 minus A is less than negative 2 and at the same time 2A plus 1 is greater than 9, we can very quickly solve those. I'm going to bring the negative A over on this side, and I'm going to add 2 to both sides. So that's going to give me, on the one hand, A is greater than 3. And on this one here, I'll go ahead and subtract 1 from both sides. So I'll get 2A is greater than 8, and I'll divide by 2. So A is going to be greater than 4. So let's make ourselves a number line here. so that we can see what's happening. And I think I'm going to color that black. Okay. And I want, on the one hand, the a's that are greater than 3. So let's turn this around so it's in English. All right, a is greater than 3. And at the same time, I want a to be greater than 4. All right, so here's 3. That will be this one. The a is greater than 3 would be these. And at the same time, I want a to be greater than 4. Okay. So that would be these. Now if I want the word and between those, the and means, so let me write these. This is my a greater than 4. Here's my a greater than 3. Then if I want to know the a's that are in that satisfy both this statement, they have to be greater than 3, and at the same time it has to be greater than 4, you can see that that's going to be where they overlap, right? Only the numbers that are greater than 4 are going to be greater than 4 and greater than 3 at the same time. So the answer to this problem right here, when you combine those together, is simply a greater than 4, and so your answer to this would be the interval that starts at 4, goes to infinity. All right, that's the answer to this one. Now you'll notice right next to it I have this same problem. The 1 minus a is less than negative 2, and I got 2a plus 1 greater than 9, but the difference is this or between them. All right, so I'm going to end up with exactly the same. If I do the algebra, I'll still get, a is greater than 3, but in this case I'll get the word or a is greater than 4. Now if I told you in my class that I will give you an A in the class if you get an A on every exam or you attend every class, that would be a very different statement than if I said I will give you an A in the class if you get an A on every exam and attend every class, right? You'd much rather just have the or statement, because you wouldn't have to get an A on the exams at all. You could just attend class. Well, that's the difference between this and or statement. So in this case, if I want the a is greater than 3 or the a is greater than 4, you see that if a is greater than 3, it's going to satisfy that or, right? Because if my a happened to be 3.5 and I'm trying to satisfy this whole mathematical statement, 3.5 is greater than 3, that's true. And it doesn't matter that 3.5 isn't greater than 4, you still will have satisfied the whole statement. So the solution to this set of inequalities, the a greater than 3 or a greater than 4, is going to be the a greater than 3. So that would be the interval from 3 to infinity. Okay?